If you rewatch the identifying acids and bases video, you'll recall that we said that adding a proton to any one of these anions made it an acid. We can now see, based on what we know about acids and bases, that these are simply the conjugate bases of the acids that are formed by adding a proton. We said that there were a few exceptions in this table in terms of which ones of these were bases, and we gave no explanation for why those were exceptions. At this point, we can understand why these are exceptions. We said that chlorate and perchlorate were not bases. However, chloric acid and perchloric acid are both acids. It turns out that those acids have really large equilibrium constants. So in this list, this is the complete list of strong acids with Kas that are large enough to be called strong acids. And so if these are strong acids, let's take the example of chloric acid and perchloric acid, then we can write that chloric acid plus water goes completely, not in equilibrium, to chlorate and H3O+. If the chlorate were to act as a base, this reaction would go in reverse. By definition, this is a strong acid, and so this reaction does not go appreciably in the reverse direction. Therefore, chlorate must not be acting as a base because it will not accept a proton from the H3O+ to form chloric acid back again. The same thing can be said for any one of the acids in this list. So the anions of these strong acids are not bases. They will not accept a proton because the parent acid is so strong that it always donates its proton to the water. Therefore, as we mentioned in the video about identifying acids and bases, we do not identify Cl-, Br-, I-, NO3-, HSO4-, ClO4-, or ClO3- as bases. They are not bases. Every other anion in this list is the conjugate base of the acid that is formed by combining the anion with H+.